To start the video, I tried to do this live. It didn't work. I looked for a few keywords, but check it out. The Osha report is out, and a Osha report is out, and we're at page 27. On page 27, we look at this awesome statement here. Of course, I'm stroking my own ego here. A review of the video publicly available on YouTube entitled, quote, FIU Florida Bridge Collapse, No Cracks, indicates that the north diaphragm was generally free of cracks at the time of the main span truss was placed on the north pylon. If you guys remember my video right here, the one 73,000 people hit on it, no cracks with great, and I added this with great close up. Also this one, no cracks. I did a few of them with that, and so here we have it. So we've got this one here, and I think people sort of slammed this, but obviously the professional engineer that wrote this report saw the significance of this data also, that he commented as such in there, that this is evidence, guys. This stuff is real that I'm sharing with you. Is awesome stuff, and my narrative as such. And this thing won't work. I tried to go live. It's just not working. So that's nice. Now let's go on. It is estimated that the truss was placed over the support around 11:30 a.m. Let me pause this and give you some. Let me just jump the jackhammer for you first. So jackhammer, as we see here, I looked up the word jackhammer as a search in this document, and on the jackhammer we see that, wow, surprisingly, on October 18th, 2017. Deck and diaphragms 1 and 2 were cast continuously in one pour. Deck and diaphragms, meaning the lower deck, right? A few days earlier, though, the casting of the deck had to be abandoned because after concrete and a few trucks were delivered, and after concrete and a few trucks were delivered, and after a portion of the deck on the south side was poured, the concrete supplier was unable to furnish a continuous supply of concrete. The concrete already placed on the deck forms had to be jackhammered and removed. Interesting, not stating what they have to redo all of the cabling now, etc. What damage took place? This is an amazing holdout, isn't it? This would be reportable to the Tiger Grant. In my opinion, this would be reported to the Tiger Grant. I could not find any Tiger Grant reportable documents that they're releasing. I am dying to see this stuff. All right, this is what I asked for also, and I couldn't get it. Okay, the diagonals and struts were cast in pour number 2, second pour, on November 6, 2017. And now we see that that's less than a month later. So this is interesting. This concrete has not reached its maximum capacity of 28 days, and they're now loading it. You'd have to figure this out, when this was actually poured. December 14th, 2017, pour number 3, canopy pour continuously. This is some awesome data here. I'm going to go over this, but I want to load up some stuff for you guys right now. I'll give you this link. You guys can research it, come back, and say, look, you're missing this, or I need to share this with you now so we can all share and enjoy it. Awesome data in here. It's simple to read, very simple, nothing. There are some technical things, and there's some awesome opinions, and I've only gleaned a few of them. I wanted to do this live with you guys, but I want to hit these photographs with you, and we're going to have to really dig into this. So if you search this document, just search 40. If you search 40, you'll get this, and it'll come to this page. And let's go ahead, and we saw these released by NTSB, but let me go up. Let me zoom out too, so I can get more pages in view for us. And let me zoom up. Okay, I just want to show you what we're looking at here. So let's zoom back in, and I'm going to hit the photographs, and then I'm going to bounce out for you guys. So now we see what it looks like. We would love to see the as-built. I'm just excited to share this with you. I have to slow down my excitement and get this to you. But let's go to, I'm sorry, let me scroll up. I just want to get you some quick photographs. And I already talked to you guys about the bracing being in place. And I did not read this fully, but apparently it's on the same page or thinking that I am, that, hey, look, it was temporarily supported, but it had that bracing too. You know, it wasn't as, you know, as it was going to be placed. So the dead load comparison is not the same because the braces were present. All right, it also depends on how it was braced supported also. So let me go back to 40 again. I'm going to do this real fast because there's some awesome more images for us. Shocking images and awesome from Osha. So this is awesome Osha report. I mean, I didn't read it all, but I'm going with awesome because it's giving us some awesome data. I can't wait to see the engineers' conclusions on this stuff. We're getting bigger images of things. Here's that crack we saw from Osha, and that's about the same. We got elevation, apparently dates. We saw this stuff in the accidental release. Interesting, in this report, we see 4, 5, and 6. I'm going to come back to that. The location. We're going to get details on that, aren't we? 4, 5, and 6 cracks develop at diagonal 11 and at its bottom chamfer. All right. So that's not the bottom chamfer. Apparently, we have different cracks under here. No concern expected by Fig. These are quotes. I don't want to dive into that yet with you guys. I'm going to let us dive into this at this point. We're gonna come back to this. This is awesome, and let me scroll up. So here we are in some awesomeness, right? Here's a mobile cell phone, number blocked, 9% battery. All this is very telling, right? Let's go ahead and zoom in on this, and we're going to snatch up data. We're looking, as a person probably would have hung it out and did like a selfie image with the camera so they could see it. And so that's perhaps why you see it pixelated. But they're trying to show the decking failing at this point, the spalling of this. And these would be indicating to me of the repair or pressure. In this case, I think it's spalling via pressure because I saw the scrap of this, what I'm calling the scrap in a moment. Interesting, the scrap, the section that came off here appears not to have fallen to the ground. Look, I don't want to analyze all this stuff in this part of the video. I'm going to come back to it. And we'll come back to who took photographs and things like that. But let's, and you should hear about the cracking and the danger that they're worried about. We're going to get into it. But looking at this in general real quickly, there is the piece missing, right? Laying on top of the rebar, the reinforcement, and at a different, that it just laid over. Now we see here that this is opening. These crack analysis, again, this is open away from the pipe. To do that, you have an entire deck you're going to have to move along with this. This piece of piping is moving with it because you can see it's pretty secure around this pipe. And in this part of the pipe, it's separated. There are those burn marks that I might have doubted and said that they were removing their whatever it was. I no longer think they were removing that because this looks like think of it like a blood spatter pattern, if you will. Something going on here, and I would love to see if it crosses over this. This would tell me when things took place. I'm going to come back to that. Here's some up here also. I'm going to come back to that. Data is the person's finger. We don't need to know who that person is because NTSB obviously does know. Okay, so this is going to be really, I'm going to come back. We're going to deep dive into this stuff, but I want to show you in general what's going on here. This looks like, you know, if you think about it, my take is just like a shear failure in the back section here because it's diagonally on a 45, if you will. Multiple cracks, which is very interesting indeed in a failure because it had 3 initial impacts is the way I look at this. And guys, I'm crazy. I break up concrete and look at this stuff and try to do analysis of cracks. And here it goes down the bottom here. And they're not compressive at this point. So this appears, this top section might have had three breaks, if you will, 1, 2, 3 peeling away in this section here, coming away from this section, raising away like a butterfly effect again. Maybe I'm psychologically stuck on a butterfly and it's pulling away in that direction. I'm going to get back to that because I'll reserve the right to change my thoughts on that. You're seeing it live, and my quick thoughts on it, and they will develop. My thoughts will. We saw this image. We're back around this pipe. I'm looking for the separation, the symmetry from this side to the other side. I do not see it. And the tips engineering room, they were wondering what this was. The one guy, I think, who attacked me. It's a coupler. That's all it is. So I'll give that to him. And yeah, he's attacking me. But remember, guys, I'm in a new... I love psychology. He has to attack me because he has no choice because of the conclusive files. He feels like I'm attacking him in his file, so he attacks back. That's his problem. I'm still willing to take data. We'll go back to this. This is awesome, though. Oh, we have symmetry. Here's our symmetry from left to right, from the right side to here. I've got my symmetry now. Oh, gosh, I've been dying for this symmetry. We have our symmetry, even the 3 paths, the 3 lines. I'm going to come back to that, but I think I'm just so excited. Let me zoom out. We've got our symmetrical failing now. I don't need to see this anymore. That I see symmetry in the diaphragm. I'm sorry for scrolling fast, guys. I want to get this video to you, and I'm gleaning what I'm looking at already. This is redundant data. Somebody picked this up and put it there, or they put this down to there. I think they picked it up and put it there to get this tape measure view, possibly to hold their hand there while they stuck the tape measure there without falling over. We'll come back to that. We're really going to deep dive into this. I need my live video working again. We already saw this from NTSBs. Oh, that's that tape measure. If I can see the top of it, I would be able to see that it is standing like proud like this. There's a tape measure going down. That's it standing up. It's 2. We can count these, how many are left over, to determine is this the actual one. It's got, let me zoom in for you. It's got the wire, come on. This fishing line, if you will. Wow, we can see down into it. It broke and fell down. We're going to get back to that. It's got this fishing line next to it. Why is that important? I need to see that that fishing line is not here. This is another photograph. It's up here. It's on the back side of it by 8 and 9 in this angle twice. Let me go back and look at this. I can't tell. That could be 2 lines, and this could be that far behind it. And then timeline. We'll go back and look at the time stamps on these 2. Now we're at 4 and 5. So yeah, the person's taking multiple depths. We're going to see if they moved it around. We're going to look at this. This is cracks at the. I'm going to come back to this stuff. I just need to share this with you. Somebody was smart enough to use a tooling to see how to probe the depth. We're going to read all their comments. But right now, I just want to get this to you in excitement and get you guys up and running. Get the other forum up and running. Yes, they may hate me, but I know some of the guys watch me there, so they need to. I need to share this link with them, and they need to get into here too. Everybody needs to get into here. We need to share this data. Now we got a ruler showing the spalling, because this is clearly not just a separation. I have to get in here to see if the piece came out. What I call spalling. I have no idea why that ruler's there besides for scale, but you're using photography. Again, guys, photography, depending on the lens you can't really use this for scale. You'd have to use a full tape measure, as we saw the NTSBs people use. Now we got depth here, image over image. That was nice. This is apparently by the, well, let's see where it is. West side of, diaphragm number 2. We shall explore this again. We're getting, well, this is, I need clarity. Give me a second. Diagonal number 11. Diaphragm 2. I need to confirm diaphragm 2, guys, for you to make sure that diaphragm 2 is diagonal 11. I need to see this state diagonal number 11 and diaphragm number 2. I'm not up to speed on my diaphragm numbering with this report. Don't be so assumptuous, if you will. Oh, I like that word. With assuming that this is diaphragm. Okay, so main deck diagonal number 2 and chamfer of diagonal number 11. Diagonal number 11 and the chamfer of diagonal number 11. So this is the chamfer here. So clearly the photographs are from NTSB with the 564 or 456 is a little bit, still needs a little adjustment. Perhaps. I reserve the right. You guys are hearing my brain working fast and on the fly. Again, I'm looking for the diaphragm number 2. Okay, so column 12, diaphragm number 2. So this is diaphragm number 2. This is where we know the photograph to be apparently from NTSB. I would love to see redundancy on that, but this appears to be the background of the water, etc. So I'm going to say that diaphragm number 2 statement is down there at the cracks that we keep observing. Excuse me for belching. So quickly scrolling on you guys. I love sharing my excitement with you on this. That this is diaphragm number 2. We have more definition of what's going on. Look at this turn. Interesting. This turn and back up again. We're done. We've got full cracks here, baby. We're definitely separated. And again, this is not compressive. This is tension. They're separating. But we do have a outward from the steel, the reinforcement bowing this out, or possibly the when it was put under compression, or the bridge is taking a twist, and that's what you get there. And I don't know what this is, a sensor. I don't know if this is a sensor or not that was left there or whatever this might be. But we're on this side of it. This diaphragm number cracks on the east side, diaphragm number 2. Okay, so that would be east side. I'm going to learn their talk now. This is east side of diaphragm. We got cracks running down. Circling, we can look at, I'm going to dive into this later, but again, this is what I noticed there. There is not symmetry here with the separation around this pipe, nor apparently around there. But this is that tight-in photograph they showed at one point. Now, I did not, so you guys know, I did not talk to the engineer that wrote this report, unless we accidentally wrote each other in the comments here. So you can read the final gist of this. We'll come back to that. But I want to troll the images real quick. This being, okay, so east, this will be west, this diaphragm number 2. Okay, note the gap indicative movement between the sleeve pipe and concrete pipe on 313. Awesome. They were talking about this, what I just mentioned a moment ago. And it says north end, so okay, I'm getting oriented. This is north towards the river, the water, the pier that fell. And this will be the west side, if that's the east. All right, so yeah, awesome. Awesome. BPA, I don't want to read his comments yet with you guys. I want to do that live if we could. Scrolling up, incidentally, I think that my title is killing me with Google because they demonetized my live stuff with you. And I dispute it, then it was monetized, and then a few hours later they took away the monetization again. I don't want to see I don't want to share with you too much of the comments. Let's see, because again, I want to get this video to you. March 17th, awesome. This is going to be good data for us. We're going to get into this when we finally get into this crack evaluation. We're going to get into it. I already talked about these scraps, and again, I had to correct myself on that. This was the post-tension bar. That I got a few things a little crooked, but it happens. That's what happens with my mind. Awesome view of this. I wish we could see if we had that data on that, whether he jackhammered in here or not, or is this just falling when the bridge collapsed, popping this stuff off. That would be another explanation of that. Okay, upper post-tension bar. Let's get into that. Beautiful, beautiful. So if you could get in closer with this, you'd see if they actually stopped at one point. Perhaps we'd see some concrete cover around here where they sealed this over at one time, or not. Maybe remember the video move, they had some apparent sealing over there. Awesome. We do not see a jackhammer out here. We know this is the equipment. We don't know what PSI it's stuck at, if any. I don't want to get into that part of the image with you. But we will take this angle here because we have not seen this. Again, no shearing taking place, pushing this off. Here's this beautiful, that format. We've got, so I'm reevaluating my statement, just so you know. And I don't see this rebar. Yeah, okay, moving on. All right, moving on. We'll come back to this stuff. Oh, beautiful. Absolutely beautiful. Screenshotting this, guys, for the thumbnail. All right. Cleaned out. We're going to come back to this, and really, I don't want to minor dive into this. I want to really deep dive into this. This is where everyone says that 11 sheared off the deck and everything else. Look here. You're looking at the missing parts, if you will. This deck around here is in great shape. The failure is the way I'm describing it. I think that the deck failed because of the dead loads of the elongation of the post-tensioning and the longitudinal cables, causing a flexural failure between 10 and 11/12, flexural bending down, which then presented the shear failure in the back of this symmetrically on left and right side, which we now know as east and west side of this, and number 12 and 11 being so engrossed with each other with the steel, it had to be ripped apart. But at one point, as it's coming apart, it pried number 12 away. That's my rough, fast version, throwing at you in supersonic speed. Now, this is more data, more of the same that I'm going to conclude. We can look down here and probably see the same. Yeah. We can even, by this material not being ripped, you can determine that the fall of this, right? It didn't even tear this material apart. We will come back to these images. We're going to deep dive into this. Oh, gosh, this is what I just described, right? This is how I just described it to you, right here. So there is west and east, and here is beautiful symmetry. Here's the symmetry that I've been dying for, right? This is the symmetry. We are definitely going to get back into this, and if only we had closer images, because you wouldn't even observe here's that cracking, I believe, that we saw 1, 2, 3 cracks. Now I could, if they were more in line a different way, we could possibly even say those cracks were because of the rebar popping them out, calling this almost like a spalling, more so than indicating of of this having that both, as I said in the beginning of the video or earlier, of this torquing left and right. I'm looking at symmetry here. I'm looking at symmetry. So you guys are hearing my brain. You're hearing me adjust. And I am back to the collapse between 10 and 11, deck failure, tensioning. Oh, I didn't search that. And, oh, this is too beautiful. We'll come back to this. We'll deep dive into it. We'll deep dive into that more. Oh, this is going to cause, yeah, we're going to really be into this. We're going to really dive into this. Lower post tension bar still embedded in concrete. So the lower post-tension bar is still embedded in concrete and in this decking. How could it cause it to push off 12 if they just showed it's still in place? So impossible to push 12 off, guys. So I know well, right now I'm psychologically fighting back right now. So sorry for my, I just caught myself. I'm going to attack the engineer tips groups with the 11 pushing off 12. We clearly see that 11 is still embedded, still in place. So, all right, perhaps that's why the engineer in this forum, in this report, tweaked me in his report, backhandedly, if you will, showing the one, not backhandedly, showing that no cracks. So, and then now we see it coming apart. At least that's my, compliment to myself. Here it is. So there it is. It's not pushing off 11. It's still embedded. It's not going anywhere. I always said it couldn't do it. So hopefully, and wow, I hate to attack those professional engineers over there. So that's not my intent. We're looking at the let me move on. We're going to come back and really dive into all this stuff. This is the transport, so obviously I used it with a crane. This is what I was so concerned about, the movement, but obviously they did an awesome job here. They even put it up on this support, apparently. I don't know. So it wouldn't create a new moment, a new issue. Yeah, we're going to be deep diving in all these images. We're coming back to this. This is when they were taking it down. I always thought that was an issue. We'll see what the report states. I'm going to back out. The post-tensioning tendons were coupled to the concrete structure by sharing the nodes. Okay, we know that. The numerical simulation of either a bonded before grouting or unbonded post-tensioning number requires an unbonded formulation to simulate the real bonding conditions between the concrete and the steel post-tension tendons. You see what he's talking about here apparently is about bonding and unbonded, that grouting thing I keep telling you guys about, that it matters. Therefore, very temperature drops were applied as inputs to different truss members so the contraction forces in the steel post-tension tendons match the actual post-tension forces in the bridge. The magnitude of the post-tension forces were adopted from the post-tension schedule prepared. Okay. I want to jump to stuff real quickly. I love their attendance format. This is visual for you guys, almost like 3D if you could visualize that. I believe this is the collapsed end, but I've got it wrong in one of our first videos, and we don't have the other one present. Oh, tendons, because that's in the compression. Totally compression. No bars were located, were installed apparently. Oh my gosh, I've been looking for this forever. So once they de-stressed the axial force of diagonal number 11 of the main span after post-tension bars were de-stressed were 1,312 quips. This, if that's the case, I believe this is what transferred down 10 roughly. And we got the concrete failure. Let me do this. Let me find 10. Oh gosh, there's a lot of 10s. I don't want to. I just want to look for 10. Remember 10, and I don't know how it would be worded. So it's pulling up everything with 10 in it. So I got to race through 10. Let me try member 10. Nothing under member 10. Number 10. Nope. I'm back to where I started. I know you guys bear with me. I want to do this live. I like the idea of live because you get to hear inside my little scroll head. The blisters at the junction of diagonals 11 and 10 were damaged, with the bottom toe tension bar extending beyond the blister, with the ram still attached. Okay. Diagonal, right. Backing up, 910. Think rightly to recognize the structural inadequacy of node 11 and 12 and presented remedial measures to capture the loads, restrain the node, and share some of the loads to the node 9/10. But at no time did FIG recommend the shoring of the bridge. All right, guys, I'm done. So there we are again. This is the 9 and 10. As you guys know, I said 9 and 10, that the loads were 9 and 10 at this point. I'm going to wrap this part of the video up, share it with you lovely people, and of course, we have to go to the top of this document. Not of course, because I didn't qualify, of course, did I? Until now. Let me go to the top of this document. So, U.S. Department of Labor, Occupational Health and Administration, June 2019. We scroll down, and the report is presented by June 2019. Professional engineer, right here, SE, Director, Office of Engineering Service, Director of Construction, Osha National Office, Washington, D.C. Awesome. Appreciate that. My little link in there. That's awesome. Did a lot of work. Glad to be part of the report in some format. Thank you for watching, guys. And I'm going to go over this. We can go over this. I mean, we got days of material here. Love it. Thank you.